Which of the following represents the approximate area under the curve of f of x is equal to 9 minus the quantity x minus 1 squared on the closed interval -2 to 4 using LRAM and 6 equal subintervals? The first thing we do is we calculate delta x when we find out that delta x is 1. And then the next thing is we just kind of come up with a quick picture of how these intervals are spread out. So this green line roughly approximates the curve of f of x. We start with -2, and since delta x is equal to 1, the width of each subinterval is equal to 1. And notice that the left-hand interval takes us from -2 to 3. That's the last rectangle where the left side touches the curve at x equals 3. So the issue is going to be, how do we relate this in a sum? How do we come up with a sequence where the first value has a c sub I of -2, the second value has a c sub I of -1, and so on? And how do we come up with this? Well, one option we have is to use a linear equations. If we go back to our earlier math studies, we know that y minus y sub 0 is equal to m times the quantity x minus x sub 0. Relating this to sequences, I can rewrite this as c sub I minus c sub 1 is equal to m times I minus I sub 1. Now, a quick note, I'm using c sub 1 and I sub 1, which is going to be the top value here. But if I chose 2, 3, or 4 on down, I would get the same expression. I would just take a little more simplification. So what I do is I replace c sub I with -2. So I'm sorry, c sub 1 with -2. So I get c sub I plus 2. My change is 1. And then I sub 1 is 1, going back to the chart over here. And when we simplify this, we have c sub I is equal to I minus 3. Now, I know some people may look at this and figure out that it's intuitive that you're just subtracting 1 minus 3 to get -2, or perhaps 3 minus 3 to get 0. But if it is not intuitive, you can't figure it out just from looking at it, you have this linear method to help you figure out the values. So now that we know that c sub I is equal to c sub I is equal to I minus 3, to find out the height of each rectangle, we calculate c sub I into the function and recall on this other page that f of x is equal to 9 minus the quantity x minus 1 squared. So I replace x with I minus 3 to get 9 minus the quantity I minus 3 minus 1, and all of that is squared. To calculate the area of each interval is delta x times f of c sub I. Delta x is 1. C sub I is this expression here. So our summation of all 6 rectangles will look like this. Now this 1 is delta x, and this entire expression is f of c sub I right here. So going over to our other page, we see that the correct answer is B.